Given the Maclaurin series, f of x equals summation from n equals 0 to infinity of negative x to the fourth quantity to the n. What is f of 3? Okay. So a Maclaurin series is a type of Taylor series. A Taylor series is where you basically use derivatives in a formula to approximate a function as a series of polynomials. You might have heard in life the term Fourier series. Fourier series is where you use sine or cosine to approximate any function using sines and cosines. The Taylor series uses polynomials, x to the power whatever, to approximate any function. So you can take a sine function and you can approximate it using x's, x squared, x cubed, etc. And that's a Taylor series. And you basically can move it to the left or right to make it more accurate depending on which point you're trying to approximate. And Maclaurin series specifically always starts at 0. That makes it convenient to memorize, and it's convenient to kind of use. So it's just a different type of Maclaurin series. But the way that's written, you don't even really need to know that. So all you care about here is, you could rewrite this as, what is summation from n equals 0 to n equals infinity of negative 3/4 to the n. As it says, we're trying to find the value of f of 3. And so we plug in 3 for x. And we're trying to find out what value this converges to. You might think that, well, we're adding up an infinite number of terms. This goes to infinity. Well, sometimes they do. This does not, though. This is specifically a geometric series. And when you see a geometric series, the way you identify it is if this value right here to the exponent is less than 1. If that's less than 1, then it'll converge to a value. Another thing to keep in mind is, for a geometric series, this value here has to be 0. If it's 1 or 2 or something different, then you can kind of add terms to the series to make it 0. But for the formula we're going to use, it has to be 0. And to the formula, we know that this equals 1 minus r to the, I'm going to say, k plus 1, all over 1 minus r. Where by k, I say that this up here, k equals infinity. First term, last term. And this goes to the last term plus 1. So what we're going to do then is, and then this r is negative 3/4. So r ratio, it's the ratio that's being geometricized, raised to a power over and over again. And so what we get then is 1 minus negative 3/4 to the infinity plus 1. I know the notation, complete abuse of notation. That's okay. We'll get over it. Well, I will at least. Negative 3/4. And so you should see, hopefully, that when you take a fraction that's less than 1, raise it to the infinity, let alone the infinity plus 1, it's going to go to 0. So, and if you don't believe me, you can take your calculator, do 3 divided by 4, which is 0.75, do it to like, I don't know, 100. It'll be pretty close to 0. This goes to 0, and what we're left with is 1 over 1 plus, because it double negatives, 3/4. Rewrite that a little bit, and we get 1 over 4 plus 3 over 4, which equals 1 over 7 over 4, which is 4/7. 4/7, and this is the answer. And your first thought might be, wait a sec, our term here is a negative. We're adding a whole bunch of negatives together. How do we get a positive? Well, the first term, which is also going to be the biggest term, is negative 3/4 to the 0, which is 1, positive 1. And then every even term will be positive. So first term is positive, every even term is positive, and so it's almost reasonable that we'll get a positive answer. And that is how you approach this problem. It's nice that it's a Maclaurin series. There's some good information behind that. But really, you just look at the data, plug in the numbers, and solve.